Hello everyone, welcome to today's class. In this class, we will be seeing the diagonal rule that is used for writing the electronic configuration of any given element or compound. So this is the pictorial view of diagonal rule that we are going to use for filling up of the electrons in the orbitals. In drawing this pictorial representation, sometimes we make mistake. So to rectify that mistake or to avoid that mistake, what you should have in mind is that the arrow is passing two times through only one. Okay, this is 1s, this is 2s. This is as a 1. The first arrow is passing through only 1s. That is only one orbital. Okay. Next time when we consider the second arrow, that is also passing through only one orbital, that is 2s, that is again 1. In the following, we have two times the arrow will be passing through only two orbitals, and further two times the arrow will pass through three orbitals. In the next two part, the arrow will be passing through four orbitals, that is 4f, 5f, 6x and 7s, and 5f, 6d, 7p and 8s. Okay, so to avoid the confusion, it's better if you remember like this, that the two arrows will be in pair, that will be passing through one orbitals, and the next two will be passing through two orbitals, and the next two will be passing through three orbitals, and next two arrow will be passing through four orbitals. I hope the confusion for the filling of the electrons in the orbitals is clear now. So let's see how much electrons can be held in each orbitals. ठीक है? We have s, p, d and f orbitals. This is different from pqrs that we have done in our earlier classes when we were dealing with just the primary model of the atom, but further on research and development, we found it to be more accurate for the filling up of electrons, that is SPDF model of filling electrons in orbitals. So S can hold up to 2 electrons in its orbital, P can hold up to 6 electrons, D can hold 10 electrons, and likewise, and further the F can hold 14 electrons in its orbital. Now let's try to see some of the examples and fill the electrons in the orbitals for that particular element. Okay, so first we will be considering sodium, for which the symbol is Na with an atomic number 11, and the its molar this is molar mass. Okay, 22.9. This is molecular weight. On the top of the element, it's given atomic number. Atomic number equal is at atomic number, what it represents is number of electrons, which is also equals to number of protons. That is the same thing. For the Na, we have atomic number 11. Okay, so we have to fill 11 in the order of 1s, 2s, 2p, 3s. See, when we are filling, we have to come like this, in this direction, downward side, like a slide. So we will be having 1s, 2s, then 2p, then 3s, and then 3p, and then 4s. So we have to fill 11 electrons in the orbitals. So we know that for the 11 electrons, okay, so for the s we have the capacity of 2, so we'll be filling 2 here, and again for the s we have capacity of 2 holding electrons, and for the p we have electron capacity of 6. So you have to count subsequently while writing the electronic configuration. Here we have completed 10 electrons. Now we will be only needed 1 electron, that is filled up in the 3s orbital. We will be removing further part. So this is our electronic configuration for the sodium, that is 1s2, 2s2, 2p6, 3s1. Now let's try to solve another example, that is of calcium with an atomic number of 20 and molecular weight of 40.08. We are just writing it, but we don't need the molecular weight, so we'll just focusing on the atomic number. So again we have to write the orbitals in the same order: 1s, 2s, 2p, then 3s, then again to the next arrow 3p, 4s. Okay, I hope it will be enough. So let's fill up. We have to fill 20 electrons. 2 we can fill here, 2 we can fill here, 6, then again 2, let's count it, 2 2 it's 10, 12, 6 again, so it's 18, and again 2. So complete, we have the number of electrons that are filled in the orbitals equals to 20. So this is our final electronic configuration for the calcium. Now let's see one more example, then we'll be finishing our class. Now let's consider the example of let's consider chlorine. Okay, so for the chlorine we have atomic number of 17 and its weight is 35.5. that is the average of two isotopes of chlorine. Okay, so this is atomic number and this is molecular weight. We are concerned only with the atomic number, so we will be filling up in the orbitals. So let's again write 1s, that is only one arrow, the second arrow that is passing through 2s, third arrow that is passing through 2p and 3s, fourth arrow that is passing through 3p and 4s, and the fourth arrow that is passing through 3d, 4p. I hope this will be enough. We have to remove only. So let's fill up. For the S we have capacity of 2, for the S capacity of 2, for the P we have capacity 6, again for the S2 let's count 2 again we have 12, and now we add 6 again to the P orbital, now we have 18. Okay, we are going further. Okay, so we'll be removing this because we have already reached the 18 counting. So for this we have only 17, so one will be removed. That is, we get our final electronic configuration for the chlorine, that is 1s2, 2s2, 2p6, 3s2 and 3p5. Hope you enjoyed this class. Thank you.